We'll be starting a new unit in math with McComish today, and it is on linear relations and equations. So this video is going to go over writing linear equations with two variables. So some things to think about, and sometimes you can think about them in different orders, but things you're going to have to work through. So number one, decide on what the variables will be. So what are the unknowns? Okay, what are we trying to find out and what is changing? Okay, so you need to ask yourself, what's the changing amount or variable and what are we going to be solving for? Number three, is there a constant? Is there something that does not change in this question? What operations will you use? And finally, you're going to write the equation. Okay, you should also check at the end to make sure that you are correct. So we're just going to look at examples. The best way to learn it is to just practice and see what you need to do. So there's two different equations we're going to do on this first question. Dennis and Joyce are helping organize a ski trip. There are T students, so that's my variable, okay, an unknown amount of students. Swift buses charge $7 a student. Zim buses charge $6 a student plus a $500 flat rate. So let's look at these questions differently. Okay, so the first section is if there are T students, Swift buses. So let's make Swift buses S because we're going to find out how much they charge. Okay, Swift buses could be S. They charge $7 a student. So to find the total cost, I would do 7 times the number of students. So my coefficient is going to be 7, and t is my variable, so 7t. So that is my equation for the first one. Okay, the cost for Swift buses equals $7 times the number of students. Okay, my next one, Zim buses charge only $6 a student. So let's say that's Z. Okay, they charge $6 a student, so it would be 6t. But they also charge a $500 flat rate to start with. So that means that is my constant. It doesn't matter how many kids go on the ski trip, you're still going to have to pay $500 for the Zim buses. So I'm just going to add this $500 as my constant, the unchanging amount. Okay, so that is my equation for the second one. Now, you could use those equations to actually find out which would be a better deal. So let's say if you had 100 students, go on it. Well, let's substitute in for this one. So this one would cost $7 times 100 students, so $700 for the Swift buses. The Zim buses would be 6 times 100 plus $500. So this would be 600 plus 500, which is $1,100. So clearly the Swift buses is cheaper in this case. Now, the more and more students you have, the more likely that the Zim buses is going to become a better deal, but not with that many students. Okay, let's say you need to take a cab ride in the city. The driver says it costs $10 just to get in and another $1.50 per kilometer traveled. Okay, so what you're going to be finding is what is my total cost. So let's say cost is C. Okay, you can make up different letters for that, but I like to relate it to what it actually is in the situation. So cost would equal. Now it's going to depend on how many kilometers I travel, right? But first, it's going to cost $10 no matter what. Even if I were just to get in the cab and get out, it costs $10 because it says it's a flat rate to start. Okay, so I'm going to $10 plus $1.50 per kilometer. So let's say that kilometer is K. I'm going to take $1.50 and times it by however many kilometers. So that's why it's $1.50K. And so I can use that to find out how far or how much it's going to cost. So let's say I'm traveling 5 kilometers. Okay, so K equals 5. Just as a random example. This, you already have the equation. So I just find the cost. I start with my $10 and do $1.50 times 5. Okay, $1.50 times 5. Well, that would give me $7.50. So that cab ride costs $17.50 in total. Okay, once you have the equation, it's not too difficult to solve the problem. Let's say a company makes colored rods by joining cubes in a row and using a sticker machine to place smiley stickers on the rods. The machine places one sticker on each face of the cube, on each exposed face. Okay, so my first cube, I might actually do a quick table of values. Cube and stickers. So on my first cube, I have 6 stickers. Okay, now if I put 2 cubes together, okay, now I'm going to actually have the exposed sides of that are 10. So there's 10 stickers. Okay, my third cube would have 14. So I'm actually increasing by 4. Okay, I'm adding 4 each time. So for every extra cube, I'm going to times it by 4. Okay, so this cube I'm going to say is C. And my stickers here could be S. All right, so the total number of stickers is going to actually be 4 times the number of cubes. Okay, it's 4C, because I'm increasing by 4 every extra cube. But I can't forget my 2 n's there. That's my constant. It's plus 2. So that's going to be my equation. Okay, one more example here. George's bank account started with $900. He spent $25 a week on food. Represent this linear relation as an equation with W representing the number of weeks compared to S showing how much money is in his bank account. So this question shows you what variables to use. So I want to know how much money is in his bank account or is in savings. Okay, he starts at $900. Okay, that's my constant. That's not going to change what I started at. Okay, what changes is how much he has in his account depending on how many weeks. So that would be W. Okay, is my changing amount. Now he's actually decreasing money because he's spending, so I'm going to be minusing that $25 per week. So minus $25 times however many weeks he has it for. Okay, so 900 minus 25 times W, times the number of weeks. Okay, so let's say he spent money for 10 weeks. Okay, so W equals 10. Okay, that would sub in 10 for W, so 900 minus 25 times 10, or 900 minus 250, so that would equal $650. But if they just ask you to write an equation, this is what your solution would be. Okay, so there's some examples. It kind of just takes practice to understand what kind of language they're using, to interpret the question, to decide what the variables are, what the constants are, what the operation is, and how they all work together. So it's time to practice some questions.